The universe is vast beyond comprehension, stretching across billions of light years, filled with wonders that would leave you speechless. But today, we're not talking about the beautiful nebula or majestic spiral galaxies that grace our astronomy textbooks. No, today we're diving into the absolute nightmare fuel that exists out there in the cosmic void. We're exploring worlds so terrifying, so utterly hostile to life as we know it, that they make the most extreme places on Earth look like tropical vacation resorts. Picture this for a moment. You wake up one morning, and instead of gentle sunlight streaming through your window, molten rock begins pelting your roof like hailstones. The ground beneath your feet isn't solid earth, but an ocean of liquid lava that stretches to every horizon. The air you try to breathe is filled with vaporized stone, and the temperature outside is hot enough to melt copper instantly. This isn't some fever dream or science fiction horror movie. This is just Tuesday morning on some of the most hellish planets we've actually discovered floating through space. What makes these worlds even more chilling is that they're real. They exist right now, spinning through the darkness, completely indifferent to our human concepts of what a planet should be like. Some of these cosmic nightmares are relatively close to us astronomically speaking, while others are so distant that their light has been travelling toward Earth since before our solar system even formed. The thing that really gets to me about these discoveries is how they completely shatter our earthbound perspective of what's possible. We live on this beautiful blue marble where water falls from the sky, where seasons change predictably, where we have breathable air and stable ground beneath our feet. We've grown comfortable with the idea that planets are supposed to be somewhat hospitable places, or at least neutral environments, where physics behaves in ways we can understand and predict. But the universe doesn't care about our comfort zones. It doesn't follow our rules or respect our assumptions about how worlds should work. Out there, in the infinite expanse of space, reality becomes stranger and more terrifying than anything our imaginations could conjure up. There are planets where the very concept of weather takes on meanings so twisted that they would drive you insane just thinking about them. Today, we're going to take you on a journey through 6 of the most horrifying exoplanets ever discovered by human science. These aren't just uncomfortable places where you might need a heavy coat or some sunscreen. These are worlds that represent cosmic horror on an unimaginable scale, places where the fundamental laws of physics create conditions so extreme that they challenge our very understanding of what a planet can be. Before we dive into this cosmic chamber of horrors, let me set the stage for what we're dealing with here. When astronomers discover exoplanets, they're not just finding random rocks floating through space. They're uncovering entire worlds with their own unique characteristics, their own weather patterns, their own geological processes, and their own ways of violating everything we thought we knew about planetary science. Some of these worlds are tidally locked to their stars, meaning one side experiences eternal day while the other endures endless night. Imagine the temperature extremes that creates. Some orbits so close to their parent stars that their surfaces are literally melting and evaporating into space. Others are so far from any source of light that they drift through the cosmic void in complete darkness, frozen and alone for billions of years. The most unsettling part about all of this is that these horrifying worlds vastly outnumber planets like Earth. For every comfortable, habitable world that might exist out there, there are probably thousands of these cosmic nightmares spinning through the darkness, each one a testament to just how hostile and strange the universe really is. As we explore these hellish worlds together, I want you to really try to imagine what it would be like to find yourself on one of these planets. Picture yourself stepping out of a hypothetical spacecraft onto surfaces that defy everything you know about solid ground. Try to visualize skies that rain, things no sky should ever rain, atmospheres that would kill you in ways you never knew were possible, and weather patterns that make Earth's most extreme storms look like gentle spring breezes. Our first stop on this tour of cosmic horror takes us to a world where the very concept of precipitation becomes something out of a nightmare. This is a place where looking up at storm clouds doesn't make you think about grabbing an umbrella. Instead, you'd be desperately searching for the strongest shelter you could find, because what falls from these skies would crush and incinerate you simultaneously. This planet represents everything wrong with assuming that other worlds work like ours. We're used to water falling from the sky. We've built our entire understanding of weather around the idea that clouds are made of water vapor, and when they get heavy enough, that water falls as rain, sleet, or snow. It's predictable, it's manageable, and it's something we can work with as a species. But what happens when you take that same basic principle and apply it to a world where the temperatures are so extreme that rocks themselves can evaporate? What happens when the thing that rises into the atmosphere isn't water vapor, but vaporized stone? What kind of precipitation do you get when the building blocks of the planet itself become the raw material for weather patterns? The answer is something so terrifying that it sounds like it came from the twisted imagination of someone trying to invent the worst possible place to exist. This is a world where solid rock becomes a gas, rises high into the atmosphere, cools down just enough to condense back into tiny fragments, and then falls back to the surface as literal stone rain. Think about that for a moment. Every single droplet in these storm clouds is a piece of rock. When the weather turns bad on this world, you don't get a gentle drizzle or even a heavy downpour. You get pelted by thousands of tiny pieces of stone falling from the sky at terminal velocity. It would be like standing in the middle of the world's most violent hailstorm, except instead of ice, you're being bombarded by fragments of granite and basalt. But that's just the beginning of this world's horrors. The reason rocks can evaporate here in the first place is because this planet orbits so incredibly close to its parent star that the daytime temperatures reach levels that would make the surface of Venus seem refreshingly cool. We're talking about heat so intense that it doesn't just melt rock, it turns solid stone into vapor that rises up into the atmosphere like steam. The star that this nightmare world orbits appears in its sky not as a distant sun like ours, but as a massive, overwhelming presence that dominates the entire horizon. If you could somehow survive long enough to witness a sunrise on this planet, which you absolutely could not, you would see that star appear as a gigantic ball of fire hundreds of times larger than our sun appears from Earth. The heat from this stellar furnace doesn't just warm the planet's surface like our sun warms Earth. Instead, it bombards this world with such intense radiation that the very ground beneath your feet would begin vaporizing the moment the star appeared over the horizon. The temperatures climb so high that the boundary between solid matter and gas becomes meaningless. Rock simply ceases to exist in solid form on the day side of this world. This creates a hellish cycle that repeats endlessly. As the planet rotates and new areas of the surface are exposed to the star's brutal radiation, more and more rock gets superheated and vaporized. This rocky vapor rises into the upper atmosphere, where it finally cools enough to condense back into solid particles. These particles then fall back toward the surface as stone rain, only to be vaporized again when they hit the superheated ground. It's like being trapped in an endless loop of geological torture, where the planet itself is being constantly destroyed and reformed by its own weather patterns. The surface must be in constant flux, with new layers of stone rain building up in some areas, while other regions are being blasted away by the intense heat and radiation. But here's where this nightmare world gets even more disturbing. This isn't a uniform hellscape where every part of the planet experiences the same conditions. Like many exoplanets we've discovered, this world is tidally locked to its star, meaning one side always faces the star, while the other side remains in permanent darkness. So, while the day side of this planet is hot enough to vaporize rock, the night side exists in eternal darkness, with temperatures cold enough to freeze almost anything solid. We're talking about temperature differences so extreme that they create their own unique forms of horror. The night side of this world reaches temperatures hundreds of degrees below zero, cold enough to freeze carbon dioxide solid. Imagine the boundary between these two extremes. There must be a narrow band around this planet where the temperature is constantly shifting between rock vaporizing heat and bone-chilling cold. This transition zone would be swept by winds carrying superheated stone vapor from the day side and frozen gases from the night side. The weather in this region would be absolutely chaotic, with temperature swings that could kill you in seconds. The more you think about the physics of this place, the more disturbing it becomes. The atmospheric pressure must be constantly fluctuating as massive amounts of rocky material transition between gas and solid states. The winds would be carrying particles of stone at incredible velocities, creating sandstorms that could strip flesh from bone in moments. And this is just our first stop on this journey through cosmic horror. This rock-raining nightmare world represents just one example of how the universe can take familiar concepts, like weather, and twist them into something so alien and hostile that they challenge our basic understanding of what a planet can be. The fact that this world exists right now, spinning through space and experiencing these conditions every single day, should fundamentally change how we think about our place in the universe. What makes this even more unsettling is that this planet didn't start out as the hellish wasteland it is today. Scientists believe it originally formed as a massive gas giant, similar to Jupiter but much larger. Over millions of years, as it spiraled closer and closer to its star, the intense radiation stripped away its thick, gaseous atmosphere, layer by layer, until only the rocky core remained. So this nightmare world is actually the skeletal remains of what was once a much larger planet. It's like looking at the bones of some cosmic giant that was slowly tortured to death by its own star. The stone rain that falls on its surface today might be the last remnants of atmospheric layers that once surrounded a planet hundreds of times larger than what exists now. This process of atmospheric stripping and planetary destruction is happening right now, in real time, as we speak. Every moment that passes, more of this world's remaining mass is being blasted away into space by the relentless radiation from its star. Eventually, even the rocky core might be completely destroyed, leaving nothing but a cloud of vaporized stone, slowly spiraling into the star that killed it. The idea that entire worlds can be slowly murdered by their own stars, reduced from gas giants to rocky cores to nothing but cosmic dust, represents a level of destruction that's almost impossible to comprehend. And this is happening not just to one planet, but to countless worlds throughout the universe, each one experiencing its own unique form of stellar torture. But as horrifying as this stone-raining world might be, it's actually one of the tamer examples of cosmic horror that we're going to explore today. The planets we'll visit next will challenge your understanding of physics in ways that make rock rain seem almost mundane by comparison. Our next destination takes us to a world that redefines the very concept of planetary rings. When you think of ringed planets, your mind probably goes to Saturn with its beautiful, delicate bands of ice and rock that look like cosmic jewelry adorning a gas giant. Saturn's rings are already impressive enough to leave astronomers speechless, stretching hundreds of thousands of miles across space in elegant, organized patterns that have captivated human imagination for centuries. But what we're about to explore makes Saturn's rings look like a child's toy in comparison. This is a world surrounded by a ring system so massive, so impossibly enormous, that it challenges everything we thought we knew about what's physically possible in planetary formation. We're talking about rings that span distances greater than the space between Earth and our Sun, rings so vast that they contain enough material to build entire planets. Picture trying to approach this nightmare world in a spacecraft. Long before you could see the planet itself, you would encounter the outer edges of its ring system. But these aren't the neat, organized bands we see around Saturn. These rings are chaotic, violent, and absolutely lethal to anything trying to pass through them. The outer rings alone extend more than 60 million miles from the planet's surface, filled with chunks of rock and ice moving at tremendous velocities. As you tried to navigate deeper into this cosmic maze, the density of debris would increase exponentially. What started as scattered particles in the outer rings would become an increasingly dangerous obstacle course of boulders, asteroids, and planetary fragments, all orbiting the central world in complex, unpredictable patterns. The gravitational forces at work here are so intense that they tear apart anything that gets too close, adding more and more material to the already overcrowded ring system. The scale of destruction required to create rings of this magnitude is almost incomprehensible. Scientists believe that this ring system formed when the planet's immense gravitational field literally ripped apart multiple moons and smaller planets that ventured too close. Imagine entire worlds, possibly Earth-sized or larger, being slowly pulled apart piece by piece until nothing remained but scattered debris orbiting their destroyer. This isn't a quick catastrophic collision like what might have formed our own moon. This is a slow, methodical process of gravitational torture that could take millions of years to completely destroy a satellite. Picture a moon trying desperately to maintain its orbit around this monster planet, but being gradually stretched and distorted by tidal forces until it finally breaks apart, adding its mass to the growing ring system. The planet at the center of this cosmic graveyard is itself a mystery wrapped in horror. Some scientists believe it might not even be a planet in the traditional sense, but rather a failed star that never quite managed to ignite nuclear fusion in its core. This would make it what's known as a brown dwarf, an object caught between being a planet and a star, too massive to be one, but not massive enough to be the other. If this theory is correct, then we're looking at something even more terrifying than a planet with massive rings. We're looking at a stellar corpse, a would-be star that failed to come to life, now slowly consuming everything around it like some cosmic vampire. The gravitational field of such an object would be powerful enough to capture and destroy planets from incredible distances, building its ring system from the remains of entire solar systems. The rings themselves aren't just passive bands of debris. They're active, dynamic systems where material is constantly colliding, fragmenting, and reorganizing itself. The inner rings move faster than the outer rings, creating shear zones where different sections grind against each other like massive cosmic gears. These collision zones generate heat and electromagnetic radiation, turning parts of the ring system into glowing bands of superheated plasma. Standing on the surface of this world, assuming it has a solid surface and you could somehow survive the crushing gravity, the view above would be absolutely terrifying. Instead of a normal sky, you would see an intricate network of rings stretching from horizon to horizon, blocking out much of the starlight and casting constantly shifting shadows across the landscape. The rings would appear to move overhead like some vast mechanical clockwork made from the bones of dead worlds. During certain orbital alignments, the rings would appear edge-on, looking like impossibly thin lines drawn across the sky. But as the planet rotated, they would gradually open up, revealing their full width and complexity. You might see gaps in the rings where the gravitational influence of surviving moons has carved out empty spaces, like missing teeth in the smile of some cosmic predator. The weather on this world would be influenced by the constant rain of ring material falling toward the surface. Unlike the stone rain we discussed earlier, this would be a slow, steady bombardment of ice, rock, and metal fragments that have been gradually spiraling inward from the ring system. The atmosphere, if one exists, would be constantly filled with meteors and shooting stars as ring debris burns up during atmospheric entry. But perhaps the most disturbing aspect of this ringed nightmare is what it represents about the nature of planetary formation and destruction in our universe. This isn't a stable, peaceful world like Earth where life could potentially develop over billions of years. This is an active zone of destruction where entire worlds come to die, where the fundamental forces of gravity and orbital mechanics create a cosmic meat grinder that tears apart anything unlucky enough to fall within its influence. The ring system we're looking at today is probably just a snapshot of this world's destructive history. Over the next few million years, the current rings will gradually spiral inward and be consumed by the central object, while new material from passing asteroids, comets, or even planets will be captured to form new rings. It's an endless cycle of capture, destruction, and consumption that has probably been going on for billions of years. What's truly chilling is that this process is happening right now, as we speak. Somewhere in this ring system, chunks of what were once complete worlds are colliding with each other at tremendous velocities, grinding themselves into smaller and smaller pieces. The debris from these collisions will eventually spiral inward, adding their mass to the central object and contributing to its ability to capture and destroy even more material. This world represents the ultimate expression of gravitational horror, a place where the same force that keeps us safely anchored to Earth's surface becomes a cosmic destroyer capable of tearing apart entire planets. It's a reminder that the universe is not a safe place, and that the forces that create and sustain worlds are the same forces that can utterly annihilate them. The rings surrounding this nightmare world contain enough material to build dozens of Earth-sized planets, but instead of being organized into stable, life-supporting worlds, all of that matter is trapped in a perpetual dance of destruction. It's like looking at a cosmic cemetery where the headstones are made from the pulverized remains of entire civilizations that might have existed on those destroyed worlds. As we prepare to leave this ringed horror behind and journey to our next destination, take a moment to consider what we've just witnessed. This isn't science fiction or fantasy. This is real physics playing out on a scale so vast that it makes our entire solar system look insignificant. Somewhere out there, in the darkness of space, this world continues its eternal process of destruction, slowly grinding up everything that comes within its reach and adding it to the ever-growing monument to cosmic violence that surrounds it. Our next stop takes us to perhaps the loneliest place in the entire universe, a world that embodies isolation on a scale that would drive any thinking being to absolute madness. This is a planet that doesn't belong to any solar system, doesn't orbit any star, and has been drifting through the absolute emptiness of interstellar space for millions or possibly billions of years. Imagine the most isolated place you can think of on Earth. Maybe it's a research station in Antarctica, or a lighthouse on a remote island, or a cabin deep in the wilderness where you can't see another human being for miles in any direction. Now multiply that feeling of isolation by infinity, because we're about to visit a world that exists in the ultimate cosmic void, forever cut off from the warmth and light of any star. This rogue planet, as scientists call it, represents one of the most psychologically disturbing concepts in astronomy. It's a world that was either born in the darkness between stars or was violently ejected from its original solar system, condemned to wander through empty space for eternity. There's no sunrise on this world, no sunset, no seasons, no day or night cycle. There is only endless, absolute darkness stretching in every direction for distances that beggar comprehension. The surface temperature on this cosmic orphan hovers around -400 degrees Fahrenheit, cold enough to freeze the air in your lungs solid before you could even attempt to breathe. But temperature is just the beginning of this world's horrors. The real nightmare is the crushing psychological weight of existing in a place where no light has touched the surface for geological ages. Picture standing on the surface of this rogue planet in a hypothetical survival suit. You turn on your flashlight and the beam cuts through the darkness, illuminating a landscape that hasn't seen light since before complex life existed on Earth. The ground beneath your feet might be covered in frozen gases that fell as snow millions of years ago and never melted. The silence would be absolute and terrifying, broken only by the sound of your own breathing and heartbeat echoing inside your helmet. But here's what makes this world even more disturbing than its obvious hostility. This planet isn't dead in the way we normally think of dead worlds. Deep beneath its frozen surface, there might still be geological activity powered by the radioactive decay of elements in its core. There could be vast underground oceans kept liquid by geothermal heat, hidden seas that have existed in total darkness for longer than our solar system has existed. Think about what that means for a moment. While this planet drifts through the cosmic void, completely cut off from any external energy source, there might be entire ecosystems thriving in those underground oceans, life forms that have evolved in complete isolation from the rest of the universe. These hypothetical creatures would have no concept of stars or light or warmth from above. Their entire evolutionary history would be shaped by the assumption that the universe is cold, dark, and empty. What kind of life could develop under such conditions? What would consciousness look like if it evolved on a world that never knew there was anything beyond its own boundaries? The very idea of such isolated evolution is deeply unsettling because it suggests forms of life so alien to our experience that we might not even recognize them as living beings. The origin story of this rogue planet adds another layer of cosmic horror to its existence. Scientists believe it was most likely ejected from its original solar system through a catastrophic gravitational encounter with a larger planet or star. Imagine the violence of that ejection, the titanic forces required to tear an entire world away from its star and hurl it into the void at speeds that would carry it between star systems. This planet might have once been a normal world with a stable orbit, perhaps even with oceans and an atmosphere warmed by its parent star. Then came the day when another massive object passed too close, and gravitational chaos ensued. In a matter of hours or days, this world went from being part of a stable solar system to being flung into the darkness at incredible velocity, never to see its star again. The psychological horror of this scenario is almost unbearable to contemplate. If there had been any form of life on this planet before its ejection, those creatures would have experienced the ultimate apocalypse. Not a quick extinction event like an asteroid impact, but a slow, inevitable freezing as their world carried them further and further away from the warmth and light they had evolved to depend on. The atmospheric collapse alone would have been terrifying to witness. As the planet moved away from its star, temperatures would have dropped rapidly. First, any surface water would have frozen solid. Then the atmosphere itself would begin to condense and fall as snow, creating blizzards of frozen air that would have lasted for years. Eventually, even the most persistent gases would freeze out of the atmosphere entirely, leaving behind a world wrapped in the silent embrace of absolute vacuum. But this rogue planet story gets even more disturbing when you consider its future trajectory. Right now, it's racing through interstellar space at tremendous velocity, but it's not heading toward any particular destination. It's simply moving through the galaxy in whatever direction the gravitational encounter that ejected it happened to point it toward. Over the next millions or billions of years, this world might occasionally pass close to other star systems, but the chances of it being captured by another star are incredibly small. More likely, it will continue its lonely journey through the void until the heat death of the universe, a cosmic wanderer that outlasts most of the stars in the galaxy, while never again feeling the warmth of stellar light. There's something profoundly melancholy about this planet's existence that goes beyond mere physical horror. It represents the ultimate expression of cosmic loneliness, a world that exists in a state of permanent exile from everything that makes planetary existence meaningful. While we worry about isolation and loneliness in our daily lives, this planet experiences isolation on a scale that renders our human concerns almost meaningless. What makes this even more unsettling is that rogue planets like this one might actually outnumber planets that orbit stars. Some estimates suggest there could be billions or even trillions of these cosmic outcasts drifting through our galaxy alone, invisible armadas of dark worlds carrying their secrets through the void. Each one represents a unique story of gravitational violence and eternal exile, a testament to how easily the universe can destroy the delicate orbital arrangements that make normal planetary systems possible. Our next destination represents a different kind of horror entirely, a world that's being slowly murdered by its own star in a process so gradual and inevitable that it makes other forms of planetary destruction seem merciful by comparison. This is a planet caught in a death spiral, literally being torn apart and consumed piece by piece by the very star it orbits. When we think about planetary destruction, we usually imagine quick, catastrophic events, like asteroid impacts or stellar explosions. But what we're about to explore is something far more sinister, a slow-motion apocalypse that takes millions of years to complete and leaves the dying world conscious of its own destruction every step of the way. This doomed planet is what astronomers call a hot Jupiter, a gas giant that has migrated inward from the outer regions of its solar system until it now orbits incredibly close to its parent star. The orbital period of this world is measured not in years or months, but in hours. It completes a full orbit around its star in just over 24 hours, moving at speeds that would make our fastest spacecraft look like they're standing still. The gravitational forces involved in maintaining such a tight, rapid orbit are absolutely enormous. The star's gravity is constantly pulling at the planet with such intensity that it has distorted the world's shape from a sphere into something more resembling a teardrop. The side of the planet facing the star is being stretched outward toward the stellar surface, while material on the far side is being pulled away into space. This gravitational stretching creates tidal forces that are orders of magnitude more powerful than anything we experience on Earth. Our moon creates tides in Earth's oceans that rise and fall by a few feet. The tidal forces on this dying world are so intense that they're literally pulling the planet's atmosphere away from its surface and feeding it directly to the hungry star. Picture watching this process from a safe distance, if such a thing were possible. You would see streams of glowing gas being torn away from the planet's surface and spiraling inward toward the star like cosmic waterfalls flowing uphill. The planet is essentially bleeding its own atmosphere into space, losing mass at a rate that will eventually result in its complete destruction. The temperatures involved in this process are beyond anything we can easily imagine. The side of the planet facing the star reaches temperatures of over 4,000 degrees Fahrenheit, hot enough to vaporize most metals and turn the very air into plasma. But it's not just the heat that's killing this world. The intense radiation from the nearby star is literally blasting away the planet's outer layers, stripping away its atmosphere molecule by molecule. What makes this scenario even more horrifying is that the planet is speeding up as it dies. As it loses mass to the star, the gravitational dynamics of its orbit change, causing it to spiral inward even faster. This creates a feedback loop, where the closer the planet gets to the star, the more rapidly it loses mass, and the more mass it loses, the faster it spirals inward. Scientists calculate that this death spiral will continue for approximately 10 million more years before the planet is completely consumed. In astronomical terms, that's practically tomorrow. We're witnessing the final chapter in the life story of an entire world, watching it being slowly digested by its own star like some cosmic python swallowing its prey. But here's where this nightmare scenario becomes even more disturbing. Recent observations have detected something that shouldn't exist on a world experiencing such extreme conditions. Despite the crushing heat, the deadly radiation, and the ongoing atmospheric destruction, There are signs of water vapor in this planet's atmosphere. The presence of water on such a hellish world raises questions that are both fascinating and terrifying. How can water exist in any form on a planet where the surface temperature is hot enough to melt copper? What does this tell us about the planet's internal structure and composition? And most unsettling of all, what might this mean for our understanding of where life could potentially exist in the universe? The most likely explanation is that this water exists in the planet's upper atmosphere, in regions that are slightly cooler than the surface, but still hot enough to kill any known form of life instantly. But the mere fact that water can persist at all in such an environment suggests that this dying world might have once been very different from what we see today. Perhaps millions of years ago, when this planet still orbited at a safer distance from its star, it might have had vast oceans and a stable atmosphere. It might have been a world where life could have developed and flourished. But as tidal forces and stellar radiation gradually dragged it closer and closer to its doom, any oceans would have boiled away, any atmosphere would have been stripped into space, and any life forms would have been incinerated long before we ever had the chance to detect them. This possibility adds a layer of tragedy to an already horrifying scenario. We might not just be watching the destruction of a planet, we might be watching the final moments in the death of an entire biosphere. The last traces of what was once a living world being consumed by the star that once gave it life. The star itself shows signs of being affected by this cosmic cannibalism. As it consumes the planet's atmosphere, it's incorporating that material into its own outer layers, changing its spectral signature in ways that astronomers can detect from dozens of light years away. In a very real sense, the star is growing fat on the remains of its planetary victim, adding the planet's mass to its own, while simultaneously destroying the world that feeds it. This process of planetary consumption might be more common in the universe than we originally thought. Many of the stars we observe might have already devoured planets in their past, leaving behind only subtle chemical signatures as evidence of their cosmic crimes. The elements we detect in stellar atmospheres might include the vaporized remains of entire worlds, complete with whatever life they might have once supported. As we watch this planet's slow death from our safe distance, we're forced to confront some uncomfortable truths about the nature of planetary systems and stellar evolution. The same gravitational forces that create stable orbits and allow planets to exist for billions of years can also drag those worlds to their destruction. The stars that provide the energy necessary for life are also capable of becoming stellar executioners, slowly murdering the very worlds they once nurtured. This dying planet will leave behind no monuments, no fossils, no trace that it ever existed beyond the slight change in its star's chemical composition. In 10 million years, when the consumption is complete, there will be no evidence that an entire world once orbited here. No way for future astronomers to know that this star once had a planetary companion that might have harboured oceans, weather systems, and possibly even life. The complete erasure of a world's existence represents perhaps the most final form of death imaginable. Not just the death of individual organisms or even entire species, but the obliteration of the very stage upon which the drama of existence played out. It's cosmic murder on a scale that makes our human concepts of mortality seem almost quaint by comparison. And yet, as terrifying as this slow-motion planetary murder might be, our next destination takes us to a world that challenges our very perception of reality itself. This is a planet that fooled astronomers for years, appearing and disappearing like some cosmic ghost, behaving in ways that violated everything scientists thought they knew about how planets should exist and move through space. Imagine discovering what you believe to be a new world orbiting a distant star, only to watch it gradually fade away before your eyes until it vanishes completely. Then picture the moment when you realize that what you thought was a planet was never a planet at all, but something far stranger and more unsettling than anyone had ever imagined possible. This phantom world first appeared in telescope observations as a faint point of light moving in an unusual orbit around one of the brightest stars visible in our night sky. The star itself is a magnificent stellar giant, twice the size of our Sun, and blazing with such intensity that it can be seen with the naked eye from Earth despite being 25 light-years away. When astronomers first detected the mysterious object, they were immediately puzzled by its behaviour. Unlike normal planets, which follow predictable elliptical orbits around their parent stars, this thing was moving along a trajectory that made no sense according to the laws of planetary motion. Its path was too eccentric, too unstable, and it seemed to be accelerating as time went on, rather than maintaining a steady orbital velocity. But what really confused scientists was how the object looked in their telescopes. Instead of appearing as a solid, well-defined planetary disk like other worlds they had observed, this phantom planet seemed fuzzy and indistinct, more like a cloud than a solid body. Its brightness fluctuated unpredictably, sometimes appearing relatively bright in infrared observations, other times fading to almost nothing. Even stranger, the object appeared to be getting larger over time, while simultaneously becoming dimmer. This combination of increasing size and decreasing brightness violated everything astronomers understood about how planets should behave when observed from a fixed distance. Planets don't grow larger or change their brightness unless something catastrophic is happening to them. For years, scientists struggled to explain what they were seeing. They proposed various theories about unusual atmospheric phenomena, exotic planetary compositions, or previously unknown physical processes that might account for the object's bizarre behaviour. Some researchers suggested it might be a planet with an extremely unusual orbit that brought it very close to its star before flinging it out to enormous distances. Others theorized that it might be a world with a highly unstable atmosphere that was being constantly replenished and then stripped away by stellar radiation. The scientific community was divided, with different research teams proposing contradictory explanations for what seemed to be an impossible astronomical object. The breakthrough came when astronomers realized they needed to completely abandon their assumptions about what they were observing. Instead of trying to force the object's behavior to fit their understanding of planetary physics, they began considering the possibility that they weren't looking at a planet at all. What they discovered was far more extraordinary than any exotic planet could have been. The mysterious object wasn't a world at all, but rather the slowly expanding debris cloud from a catastrophic collision between two massive asteroids or planetary embryos that had occurred just as astronomers began observing the system. Think about the incredible coincidence involved in this discovery. Somewhere in space, two large chunks of rock that had been orbiting peacefully for millions or billions of years suddenly collided with tremendous violence, creating an explosion that scattered debris across millions of miles of space. And this collision happened to occur at precisely the moment when human astronomers were pointing their most advanced telescopes at that particular star system. The collision itself must have been absolutely spectacular, involving energies that dwarf anything we can imagine on Earth. When two asteroid-sized objects collide at the orbital velocities typical of planetary systems, they don't just crash into each other like cars in a traffic accident. They essentially vaporize each other, creating expanding clouds of superheated gas, molten rock, and microscopic dust particles that spread outward from the impact point at tremendous speeds. What astronomers had been observing for years was this expanding debris cloud, which explained all of the mysterious behaviors that had puzzled them. The cloud appeared to be moving along an unusual trajectory because it wasn't bound by the gravitational constraints that govern solid planets. It was simply expanding outward from the collision point, while also orbiting the star according to the momentum imparted by the original impact. The increasing size and decreasing brightness made perfect sense once scientists realized they were watching debris spread out over an ever larger volume of space. As the collision products expanded, they became more diffuse and harder to detect, which is why the object seemed to fade away over time until it eventually disappeared entirely from telescopic observations. But the truly mind-bending aspect of this discovery is the timing involved. Asteroid collisions of this magnitude are incredibly rare events in any given planetary system. The odds of one occurring during the brief window of human astronomical observation are so small as to be almost impossible, yet it happened and we were there to witness it. This phantom planet represents something deeply unsettling about our understanding of the universe and our place within it. For years, the scientific community was convinced they were studying an exotic but real planetary body. Researchers wrote papers about its unusual properties, developed theories to explain its behavior, and incorporated it into their models of planetary system formation and evolution. Then, in what must have been a humbling moment for astronomy, they discovered that the object they had been studying so intensively simply didn't exist. Not only was it not a planet, it wasn't even a permanent astronomical body at all. It was just a temporary cloud of debris that happened to be visible during the infinitesimally brief moment when humans developed the technology to observe it. This discovery raises profound questions about how much of what we think we know about the universe might be based on similar misunderstandings. How many other astronomical objects that we confidently classify as planets, stars, or galaxies might actually be something completely different? How often are we fooled by cosmic phenomena that masquerade as something familiar while actually representing entirely unknown processes? The phantom planet also serves as a stark reminder of how violent and chaotic planetary system formation really is. We tend to think of solar systems as orderly, stable arrangements where planets follow predictable orbits for billions of years. But the reality is that planetary systems are constantly evolving, with objects regularly colliding, being ejected into interstellar space, or being consumed by their parent stars. The collision that created our phantom planet involved the complete destruction of what might have been two substantial worlds in their own right. If either of those objects had survived instead of colliding, they might have eventually grown into full-sized planets with their own unique characteristics and possibly even the potential to support life. Instead, in a moment of cosmic violence that lasted only seconds, both objects were utterly annihilated, their mass scattered across space as an expanding cloud of debris that briefly fooled human astronomers before fading into invisibility. It's a sobering reminder of how fragile planetary formation really is, and how easily entire worlds can be erased from existence by random gravitational encounters. What makes this story even more haunting is that we'll probably never know what those original objects were really like before their destruction. Were they rocky asteroids, metallic planetesimals, or something more complex? Did either of them have the potential to eventually become a habitable world if they had been left alone to continue their orbital evolution? These questions will remain forever unanswered because the collision that created our phantom planet was so complete that it vaporized any evidence of what the original objects might have been. All that remains is the fading signature of their destruction, slowly dispersing into the cosmic background until even that trace disappears entirely. Our final destination on this journey through cosmic horror takes us to a world so ancient that it challenges our understanding of when and how planets can form in the universe's history. This is a planet that has been wandering through space since the very dawn of creation, a cosmic survivor that has witnessed the birth and death of countless stars while remaining essentially unchanged for billions of years. To put this world's age in perspective, consider that our entire solar system, including Earth and all life upon it, represents just the most recent quarter of this ancient planet's existence. When this world was already middle-aged, our sun hadn't even begun to form from the primordial gas clouds that would eventually become our solar system. This planet is so old that it predates most of the heavy elements that make up rocky worlds like Earth. The star that this ancient world orbits is equally remarkable and equally disturbing in its own way. It's what astronomers call a red subdwarf, a type of star that burns so slowly and efficiently that it can continue shining for trillions of years. But this stellar longevity comes at a cost that makes this system uniquely terrifying in its implications for any potential life that might exist there. This red subdwarf produces only a tiny fraction of the light and heat that our sun generates. It's so dim that the ancient planet must orbit incredibly close to the star just to receive enough energy to maintain liquid water on its surface. The planet completes an orbit around its feeble star in just over 48 days, circling at a distance that would place it well inside Mercury's orbit if it were in our solar system. But here's what makes this scenario particularly unsettling from a biological perspective. The planet is almost certainly tidally locked to its star, meaning that one hemisphere experiences eternal daylight while the other endures permanent darkness. The boundary between these regions would be a twilight zone of perpetual dawn or dusk, where temperatures might be suitable for liquid water to exist. Now imagine what nearly 12 billion years of evolution might produce on a world with such extreme and stable environmental conditions. On Earth, evolution has produced incredible diversity in just 4.5 billion years, from the first simple cells to human civilization. What might arise given almost 3 times that amount of time on a world with completely different environmental pressures? The dark side of this ancient planet would be a realm of perpetual winter, where any atmosphere would condense into snow and ice. But the day side would be bathed in constant, dim red light from the subdwarf star, creating conditions unlike anything that has ever existed on Earth. Plants, if they evolved on this world, would need to be adapted to the deep red light of their star rather than the broad spectrum illumination we're familiar with. But it's the potential for intelligent life that makes this ancient world truly disturbing to contemplate. If consciousness arose on this planet, even relatively recently in its history, say within the last billion years, those beings would have had 1,000 times longer than human civilization to develop technology, philosophy, and understanding of the universe. What would a species look like after 1 billion years of continuous development? What kind of technology would they possess? What would their understanding of physics and cosmology encompass after having observed the universe for such an incredible span of time? They would have watched entire generations of stars be born, live their lives, and die while their own world continued its ancient orbit around its dim, long-lived sun. The psychological implications of such longevity are almost impossible to grasp. These hypothetical beings would have had time to explore not just their own solar system, but potentially vast regions of the galaxy. They might have witnessed the formation of our own solar system, watched our sun ignite for the first time, and observed the early evolution of life on Earth from across interstellar distances. If such beings exist, they would possess a perspective on cosmic time that would make them essentially godlike compared to any species that evolved more recently. They would have had time to solve scientific problems that we're only beginning to grapple with, to develop technologies that seem like magic to us, and to accumulate cultural and philosophical knowledge across timescales that render human history insignificant. But there's also something deeply melancholic about this scenario. If intelligent life did arise on this ancient world, those beings would have experienced the ultimate cosmic loneliness. They would have been alone in the universe for billions of years before any other technological civilizations arose anywhere else in the galaxy. They would have had no peers, no equals, no one to communicate with across the vast distances between stars. Perhaps even more disturbing is the possibility that such beings might still exist today, watching our young species take its first tentative steps into space while possessing knowledge and capabilities that we couldn't comprehend even if they tried to share them with us. We might be living under the observation of intelligences so ancient and advanced that we appear to them as bacteria appear to us. the ancient planet itself would bear the scars and modifications of billions of years of potential habitation. If technological beings did evolve there, they would have had more than enough time to completely reshape their world according to their needs and desires. The surface might be covered with structures and engineering projects on a scale that spans continents or even the entire planet. But perhaps the most unsettling possibility is that this ancient world might now be empty, its former inhabitants having transcended physical existence, died out, or moved on to other realms of existence that we can't even imagine. The planet might be a cosmic museum preserving the remains of a civilization so old that it predates every other form of complex life in the known universe. Standing on the surface of this world, in that twilight zone between eternal day and endless night, you would be walking on ground that has remained essentially unchanged since before our solar system existed. The rocks beneath your feet would have formed when the universe was less than a quarter of its current age, when the first generation of stars was still burning hydrogen in the cosmic darkness. The silence on such a world would be profound beyond description. If no life exists there now, it would be a silence that has persisted for geological ages, broken only by the occasional impact of meteorites or the slow grinding of tectonic forces. But if ancient beings still inhabit this world, their presence would be even more unsettling than their absence, representing forms of consciousness and intelligence that have had billions of years to evolve beyond anything we can recognize or understand. This ancient planet forces us to confront the possibility that we are not among the first intelligent species to arise in our galaxy, but rather among the last. It suggests that the universe might be filled with civilizations so old and advanced that they exist on timescales and in ways that make them essentially invisible to our young science and technology. As we conclude our journey through these cosmic nightmare worlds, we're left with a profound sense of how hostile and strange the universe really is. From planets where rocks fall like rain to worlds being slowly consumed by their own stars, from phantom planets that never existed to ancient worlds that predate almost everything we know, these discoveries shatter our comfortable assumptions about what planets can be and where life might exist. Each of these worlds represents a different form of cosmic horror, but they all share one common characteristic. They remind us that Earth's comfortable, stable environment is not the norm in our universe. We live on an incredibly rare type of world, one where conditions have remained suitable for life for billions of years without catastrophic interruption. The universe is vast beyond comprehension, and most of it consists of environments that would kill us instantly. These horrifying planets we've explored today are not exceptions or curiosities. They represent the norm, while worlds like Earth are the strange anomalies that somehow manage to avoid the countless forms of destruction and chaos that characterize most planetary environments. But perhaps most disturbing of all is the realization that these nightmare worlds are out there right now, spinning through space, experiencing their various forms of cosmic horror, whether we observe them or not. The rock rain is falling, the rings are grinding up the remains of dead worlds, the phantom collisions are creating temporary debris clouds, the planetary death spirals are continuing their inevitable conclusions. The rogue planets are drifting through the void, and the ancient worlds are maintaining their billion-year vigils in the darkness. This is the universe we live in, a cosmos where the beautiful and the terrifying exist side by side, where the same physical laws that allow life to flourish can also create conditions of unimaginable hostility. Our small blue planet represents a tiny island of stability and comfort in an ocean of cosmic chaos, and recognizing that fact should fill us with both wonder at our good fortune and humility about our place in the grand scheme of existence. The next time you look up at the night sky and see those distant points of light, remember that each one might be illuminating worlds beyond our wildest nightmares, planets where the very concept of habitability has been twisted into forms that challenge our understanding of what's possible in this strange and terrifying universe we call home. These cosmic nightmares we've explored represent just a tiny fraction of the horrors that exist in our universe, but they serve as windows into the darker aspects of planetary formation and stellar evolution. What makes these discoveries even more chilling is that astronomers are finding new nightmare worlds almost every month, each one revealing previously unknown ways that physics can torture matter into configurations that defy our earthbound understanding of how worlds should behave. The technology we use to detect these distant horrors is constantly improving, allowing us to peer deeper into space and further back in time than ever before. With each new generation of telescopes and detection methods, we're uncovering planets that are even more bizarre and hostile than the ones we've already discovered. The James Webb Space Telescope and other advanced instruments are revealing atmospheric compositions, surface conditions, and orbital dynamics that push the boundaries of what we thought was physically possible. But here's what keeps astronomers awake at night. For every horrifying exoplanet we've managed to detect and study, there are probably thousands more nightmare worlds that remain hidden from our instruments. The methods we use to find planets favor the detection of large worlds that orbit close to their stars, which means we're likely missing countless smaller horror planets that exist in the outer reaches of distant solar systems. Think about that for a moment. The cosmic chamber of horrors we've explored today represents just the tip of an iceberg, so massive that it defies comprehension. Somewhere out there in the darkness, there are probably planets where the weather consists of diamond dust storms driven by winds that move at significant fractions of the speed of light. There might be worlds where the surface gravity is so intense that atomic nuclei themselves begin to deform under the pressure. The diversity of planetary nightmares appears to be limited only by the laws of physics themselves. And as we're learning, those laws permit configurations of matter and energy that our imaginations struggle to encompass. Each new discovery forces us to expand our definition of what constitutes a planet and challenges our assumptions about the range of environments that can exist in nature. Consider the implications of what we've learned about planetary formation through studying these nightmare worlds. The same gravitational and thermodynamic processes that created our comfortable Earth are capable of producing the rock-raining hellscapes and tidally shredded gas giants we've encountered today. The difference between a life-supporting world and a cosmic torture chamber often comes down to small variations in orbital distance, stellar mass, or the timing of planetary migration during system formation. This realization should fundamentally change how we think about the search for life in the universe. While we've focused our efforts on finding planets in the so-called habitable zones around their stars, we now know that being in the right orbital distance is just one of countless factors that determine whether a world becomes a paradise or a nightmare. The atmospheric dynamics alone on these horror planets reveal processes that don't exist anywhere in our solar system. We're discovering worlds with weather patterns so violent and exotic that they require entirely new branches of atmospheric physics to understand. There are planets where the day-night temperature differential creates wind speeds that would strip atoms apart, and worlds where the atmospheric chemistry produces precipitation that would be toxic to any conceivable form of life. But perhaps the most unsettling aspect of these discoveries is how they illuminate the sheer randomness of planetary fate. The difference between becoming a habitable world like Earth and becoming one of these cosmic nightmares often comes down to chance encounters with other celestial bodies during the chaotic early stages of solar system formation. A slightly different orbital resonance, a marginally larger or smaller stellar mass, or a random gravitational perturbation during planetary migration could have easily turned Earth into any of the horror worlds we've explored today. The rogue planets drifting through interstellar space represent perhaps the most existentially terrifying category of worlds, because they demonstrate how easily entire planets can be ejected from their home systems and condemned to eternal isolation. Current models suggest that such ejection events might be common during the early evolution of planetary systems, which means there could be billions of these cosmic outcasts wandering through our galaxy alone. Each of these orphaned worlds carries with it the complete destruction of whatever potential for life it might have once possessed. Any ecosystems that might have developed during their time in stable orbits would have been flash frozen as the planet carried them into the cosmic void. The archaeological record of entire biospheres might be preserved in the ice layers of these rogue worlds, waiting for some future civilization to discover and decode the history of life that once flourished before being cast into darkness. The planets, being consumed by their own stars, present a different kind of horror, one that unfolds over geological timescales, but is no less final in its outcome. These worlds are experiencing death by 1,000 cuts, losing mass gradually over millions of years, while remaining conscious of their own destruction throughout the entire process. The fact that some of these doomed planets still show signs of atmospheric water vapor suggests that they might once have been very different worlds, perhaps even habitable ones, that supported oceans and weather systems before being dragged into their stellar executioners. What makes this scenario particularly disturbing is that it might represent the eventual fate of many planetary systems as they evolve over cosmic time. The gravitational interactions that make planetary systems dynamic and interesting are the same forces that can eventually lead to planetary consumption, orbital decay, and the complete sterilization of entire solar systems. The ancient worlds we've discovered force us to confront the possibility that intelligence and civilization might be far more common in the universe than we've assumed, but existing on timescales that make detection and communication almost impossible. If technological species can arise and survive for billions of years, they would accumulate knowledge and capabilities that would make them effectively godlike compared to younger civilizations like our own. The implications of this possibility are both thrilling and terrifying. It suggests that the universe might be filled with forms of consciousness and intelligence that operate on scales we can barely imagine. These ancient beings might view the rise and fall of entire species and civilizations the way we observe the seasonal changes in plant life as natural cycles that occur within timeframes too brief to warrant much individual attention. But it also raises the possibility that we're not alone in our cosmic neighborhood, that ancient eyes might be watching our young species as we take our first tentative steps into space exploration. If such beings exist, they would possess perspectives on cosmic evolution that could answer our deepest questions about the nature of existence, the likelihood of life arising elsewhere, and the ultimate fate of intelligence in an expanding universe. The phantom planets that turn out to be collision debris clouds reveal just how violent and chaotic the process of planetary system formation really is. What we observe today as stable, orderly arrangements of planets around stars is actually the end result of billions of years of gravitational warfare, where countless worlds were destroyed, ejected, or consumed during the complex dance of orbital evolution. Every mature planetary system represents a battlefield littered with the remains of worlds that didn't survive the formation process. The asteroid belts, comet clouds, and scattered debris disks we observe around other stars are probably the graveyards of planets that might have become habitable worlds if they had managed to avoid catastrophic collisions during their system's chaotic youth. This realization transforms our understanding of how rare stable planetary systems might actually be. For every system like ours that managed to settle into a relatively peaceful configuration, there might be dozens of others that tore themselves apart through gravitational interactions, leaving behind only scattered debris as evidence of their former existence. The ring systems that dwarf Saturn's magnificent bands represent monuments to destruction on a scale that challenges our ability to comprehend. These cosmic graveyards contain the pulverized remains of entire worlds, ground up by gravitational forces over millions of years and spread into elaborate patterns that stretch across distances larger than the orbit of Earth around our Sun. Standing on one of the moons within such a ring system, you would witness a view that perfectly encapsulates the dual nature of cosmic beauty and horror. The rings would arch overhead in intricate, ever-shifting patterns of breathtaking complexity, but every particle in those rings would represent a fragment of some world that was torn apart by the same gravitational forces that created the spectacular display. These ring systems are also dynamic, constantly evolving as new material spirals inward to be consumed by the central planet, while fresh debris from destroyed moons and captured asteroids replenishes the outer bands. They represent ongoing processes of destruction that have been continuing for millions of years and will continue for millions more. Cosmic meat grinders that turn entire worlds into spectacular but deadly works of gravitational art. As we push the boundaries of exoplanet detection and characterization, we're beginning to discover worlds that exist in configurations so extreme that they challenge our basic understanding of planetary physics. There are planets that orbit so close to their stars that their surfaces are literally boiling away into space, creating comet-like tails of vaporized rock that stretch for millions of miles behind them as they race around their orbits. Other worlds exist in binary star systems where they experience double sunrises and sunsets, but with stellar companions so different in mass and temperature that the planet's climate undergoes radical changes depending on which star is dominant at any given time. The complex orbital dynamics in such systems can create seasonal variations so extreme that they would make Earth's ice ages look like minor temperature fluctuations. We're also discovering planets in systems with multiple stars, where gravitational interactions create orbital patterns so complex that predicting the planet's position requires solving mathematical equations that push the limits of our computational capabilities. Some of these worlds experience periods of stability, followed by chaotic intervals, where their orbits become wildly unpredictable, creating climate variations that would make long-term evolution of complex life virtually impossible. The atmospheric compositions we're detecting on some exoplanets reveal chemical processes that don't exist anywhere in our solar system. There are worlds where the atmosphere is so rich in heavy metals that it literally rains liquid mercury, and planets where the atmospheric pressure is so extreme that carbon dioxide exists in states of matter that we can barely recreate in laboratory conditions. These exotic atmospheric conditions create weather patterns that defy our Earth-based intuitions about how planetary climates should work. There are worlds where the temperature differential between day and night sides creates atmospheric circulation patterns so violent that they redistribute heat through shock waves that propagate around the planet at supersonic speeds. The magnetic fields around some of these nightmare planets are so intense that they would strip the electrons from atoms, creating radiation environments that would sterilize any potential life forms almost instantly. These magnetic phenomena also interact with stellar wind in ways that create auroral displays visible from interstellar distances, turning the planets into cosmic lighthouses that advertise their hostility to any potential visitors. But perhaps the most philosophically disturbing aspect of these discoveries is what they tell us about the nature of habitability in the universe. We've learned that the conditions necessary for life, as we know it, are far more fragile and unlikely than we originally believed. The delicate balance of factors that make Earth habitable could be disrupted by countless different mechanisms, most of which we're only now beginning to understand through studying these nightmare worlds. The sheer diversity of ways that planets can become uninhabitable suggests that worlds like Earth are not just rare, but almost impossibly unlikely. For every parameter that affects habitability, There appear to be dozens of ways that parameter can be pushed into ranges that make life impossible. Orbital eccentricity, stellar variability, atmospheric composition, magnetic field strength, planetary mass, rotation rate, and countless other factors all have to fall within very narrow ranges for a world to remain habitable over geological timescales. This growing understanding of planetary habitability constraints is forcing astronomers to revise their estimates of how common life might be in the universe. While the sheer number of exoplanets we've discovered suggests that planetary formation is a common process, the fraction of those worlds that might actually be capable of supporting life appears to be vanishingly small. Yet even as we uncover more and more nightmare worlds, we also occasionally discover planets that appear to exist in potentially habitable configurations. These rare gems shine like beacons of hope in a cosmos that seems overwhelmingly hostile to life, reminding us that while nightmare planets might be the norm, the universe is vast enough that even incredibly unlikely configurations can occur somewhere among the billions of worlds that exist in our galaxy alone. The technology we're developing to study these distant worlds is also revealing details about planetary formation and evolution that were completely unknown just a few decades ago. We can now detect the chemical signatures of specific molecules in exoplanet atmospheres, measure the temperatures and wind speeds on worlds dozens of light years away, and even begin to map the surface features of some nearby exoplanets. This growing capability to characterize exoplanet environments in detail is opening up entirely new fields of comparative planetology that will help us understand not just how nightmare worlds form and evolve, but also what conditions are necessary to prevent planets from becoming uninhabitable horror shows. By studying the full spectrum of planetary environments, from the most hellish nightmare worlds to potentially habitable oases, we're building a comprehensive understanding of planetary science that will guide our search for life beyond our solar system. The nightmare planets we've explored today represent just the beginning of what promises to be an ongoing revelation of cosmic horror as our detection capabilities continue to improve. Each new discovery adds another piece to the puzzle of planetary formation and evolution, while simultaneously expanding our appreciation for just how strange and hostile the universe can be. As we continue to push the boundaries of exoplanet science, we can expect to discover worlds that are even more bizarre and terrifying than the ones we've encountered today. The universe has had over 13 billion years to experiment with different combinations of matter, energy, and gravitational dynamics, and we're only now beginning to catalogue the results of those cosmic experiments. What we've learned from studying these nightmare worlds should fill us with both terror and wonder. Terror at the realization of how many different ways that planetary environments can become utterly hostile to life, and wonder at the incredible diversity of physical processes that can shape worlds in ways we never imagined possible. But perhaps most importantly, these discoveries should give us a profound appreciation for the extraordinary planets we call home. Earth's stable climate, protective magnetic field, breathable atmosphere, and countless other life-supporting characteristics represent a combination of factors so unlikely that it borders on the miraculous. Every sunrise we witness, every breath of air we take, every drop of liquid water we drink represents a victory over the cosmic forces that have turned billions of other worlds into the nightmare planets we've explored today. We are living on an island of habitability in an ocean of cosmic horror, and recognizing that fact should inspire us to protect and cherish the extraordinary world that has given rise to our existence and consciousness. The universe is vast, strange, and filled with wonders that challenge our understanding of what's possible. But it's also overwhelmingly hostile to life, dominated by nightmare worlds that remind us just how fortunate we are to exist on one of the rare planets where conditions have remained suitable for the development and survival of complex life over billions of years. As we continue to explore the cosmos and discover new worlds beyond our solar system, we'll undoubtedly encounter even more horrifying examples of what planets can become when the delicate balance of habitability is disrupted. But we'll also continue searching for those rare worlds that might share Earth's extraordinary characteristics, hoping to find other oases of habitability in the cosmic wilderness. The journey through these nightmare planets has taken us to the darkest corners of our universe, revealing forms of planetary horror that exceed our wildest imaginings. Yet this exploration has also deepened our understanding of planetary science and given us new appreciation for the remarkable world we inhabit. In the end, these cosmic nightmares serve as both warnings and teachers, showing us the countless ways that worlds can fail to support life, while simultaneously highlighting the incredible series of fortunate circumstances that have allowed our own planet to become the beautiful, life-supporting oasis we know today. The mysteries of planetary formation continue to unfold before us in ways that challenge everything we thought we understood about how worlds come into existence. As we venture deeper into this cosmic catalogue of horrors, we encounter phenomena so bizarre that they force us to completely reimagine what it means for a planet to exist in our universe. Our journey now takes us to a realm where the very concept of planetary identity becomes fluid and uncertain. Picture a world that exists in a state of constant transformation, where the boundary between planet and star becomes blurred beyond recognition. This is a place where the fundamental categories we use to classify celestial objects break down entirely, leaving us with something that defies our most basic astronomical definitions. What we're about to explore challenges the core assumption that planets are stable, well-defined objects that maintain their essential characteristics over time. Instead, we're venturing into territory where worlds exist in states of perpetual metamorphosis, constantly shifting between different phases of existence in ways that would make our concept of planetary stability seem like a comforting illusion. The object at the center of this particular nightmare scenario exists in a twilight zone between planet and failed star. It's massive enough to generate its own heat through gravitational compression, yet not quite massive enough to ignite the nuclear fusion reactions that would transform it into a true star. This places it in a category that astronomers struggle to define, something that exists in the liminal space between planetary and stellar existence. Picture trying to approach this enigmatic world in a hypothetical spacecraft. As you draw closer, you would encounter something that looks like a planet from a distance, but reveals increasingly star-like characteristics as you approach. The surface, if such a thing can even be said to exist, would be a roiling mass of superheated gases and plasma, constantly convecting and churning like the atmosphere of a failed star. The temperatures on this world reach levels that make the hottest planets we've discussed seem relatively cool. We're talking about surface conditions, where the distinction between solid, liquid, and gas becomes meaningless, where matter exists in states that can only be described as plasma. The heat generated by this world's own gravitational compression creates an environment so extreme that it glows with its own light, visible across interstellar distances. But what makes this object truly disturbing is its relationship with the star it orbits. Rather than maintaining the respectful distance that characterizes normal planetary systems, this massive world interacts directly with its parent star through gravitational forces so intense that they distort both objects. The star itself shows signs of being affected by its massive companion, with material flowing between the two bodies in complex patterns that blur the line between planet and star. The gravitational dance between these two objects creates tidal forces that dwarf anything we've encountered in our previous explorations. The planet is constantly being stretched and compressed by its star's gravity, while simultaneously exerting its own gravitational influence on the stellar surface. This creates a feedback loop of mutual distortion that makes both objects inherently unstable. The orbital dynamics of this system are so complex that predicting the planet's future becomes almost impossible. Computer models suggest that the system could exist in its current state for millions of years, or it could undergo catastrophic changes within decades. The uncertainty itself is part of what makes this world so unsettling, representing a form of cosmic unpredictability that challenges our desire to understand and categorize celestial phenomena. What's particularly disturbing about this scenario is that we might be witnessing the birth of something entirely new in astronomical terms. If this massive planet continues to accrete material from its parent star, it might eventually reach the critical mass necessary to ignite nuclear fusion and become a star in its own right. This would transform the entire system from a single star with a massive planet into a binary star system, fundamentally altering the gravitational dynamics and destroying any other planets that might exist in the system. Alternatively, the gravitational interactions between the planet and star might eventually become so intense that one or both objects are torn apart, creating a debris field that could persist for millions of years before eventually coalescing into entirely new configurations of matter. The system represents a crossroads in cosmic evolution, where multiple possible futures exist simultaneously until gravitational dynamics force a resolution. The atmospheric conditions on this world, assuming it has what could be called an atmosphere, would be unlike anything else we've encountered. The boundary between the planet's surface and its atmosphere would be arbitrary at best, with gases heated to stellar temperatures, creating convection patterns that extend far into space. These atmospheric dynamics would generate magnetic fields so intense that they could affect spacecraft systems from distances of millions of miles. The electromagnetic radiation emitted by this world spans the entire spectrum from radio waves to X-rays, creating a hostile radiation environment that would make approach by any conceivable spacecraft extremely dangerous. The planet essentially acts as a beacon of deadly energy, broadcasting its existence across interstellar space while simultaneously warning away any potential visitors. But perhaps the most philosophically troubling aspect of this world is what it tells us about the arbitrary nature of astronomical classifications. We've grown comfortable with the idea that planets and stars are fundamentally different types of objects, but this world exists in the grey area between these categories, forcing us to confront the possibility that our classification systems are more arbitrary than we'd like to admit. The existence of objects that blur the boundaries between planets, stars, and other celestial bodies suggests that the universe is far more fluid and dynamic than our terrestrial experience would suggest. The categories we use to make sense of cosmic phenomena might be convenient fictions that help us organize our understanding, but don't reflect the true complexity of how matter and energy interact on cosmic scales. As we observe this world from our safe distance, we're forced to confront the limitations of human understanding when faced with cosmic phenomena that don't fit neatly into our preconceived categories. The universe doesn't organize itself according to our convenience, and objects like this massive planet-star hybrid remind us that reality often exceeds the boundaries of our classification systems. Moving beyond this liminal nightmare, our exploration takes us to a world that represents a different kind of horror entirely. This is a planet that has been completely sterilized by cosmic radiation, transformed into a dead zone where no form of matter can maintain its molecular structure for more than brief moments before being torn apart by high-energy particles. The star that this radiation-blasted world orbits is what astronomers call a pulsar, the collapsed remnant of a massive star that underwent a catastrophic supernova explosion. What remains is an object so dense that a teaspoon of its material would weigh as much as Mount Everest, spinning hundreds of times per second, while generating magnetic fields trillions of times stronger than Earth's protective magnetosphere. The pulsar's rotation creates lighthouse beams of radiation that sweep across space at regular intervals, and this unfortunate planet happens to lie directly in the path of these cosmic death rays. Every few seconds, the planet's surface is bathed in radiation so intense that it breaks apart atomic nuclei, reducing any complex molecules to their constituent particles almost instantaneously. Picture standing on the surface of this radiation-scorched world during one of these pulsar sweeps. The landscape around you would literally glow as the intense radiation interacted with matter at the atomic level, creating auroral displays that would be visible even in daylight. But these beautiful light shows would be the visible manifestation of processes that were sterilizing everything they touched, breaking down the very atoms that make up solid matter. The surface of this world would be constantly changing as the pulsar radiation altered the atomic structure of rocks and minerals, creating new isotopes and compounds that couldn't exist under normal circumstances. The planet serves as a natural laboratory for studying matter under the most extreme radiation conditions possible, revealing atomic processes that can't be replicated in any earthbound particle accelerator. But the true horror of this world lies not in its current state, but in its past. Pulsars are created when massive stars explode as supernovas, events so violent that they can sterilize entire solar systems. This planet somehow survived the supernova that created its pulsar companion, which means it experienced the ultimate cosmic apocalypse and lived to tell the tale. The supernova explosion that created this system would have subjected the planet to temperatures and radiation levels that defy comprehension. For a brief period, the dying star would have shone with the brightness of an entire galaxy, pumping out more energy in a few seconds than our sun will produce over its entire 10 billion year lifetime. The planet's survival through such an event suggests that it once possessed characteristics we can barely imagine. Before the supernova, this world might have been a normal, possibly even habitable planet, orbiting a massive but stable star. It might have had oceans, an atmosphere, and potentially even life. The supernova would have instantly vaporized any atmosphere, boiled away any oceans, and sterilized every square inch of the surface down to depths of hundreds of meters. What we see today is essentially the skeletal remains of whatever this world once was, stripped of everything that made it recognizable as a planet and reduced to a bare rocky core that serves as a target for the pulsar's relentless radiation bombardment. It's a testament to both the incredible destructive power of stellar evolution and the remarkable resilience of solid matter under the most extreme circumstances imaginable. The orbital dynamics of this system add another layer of horror to an already nightmarish scenario. The planet's orbit around the pulsar is gradually decaying due to the emission of gravitational waves, meaning that it's slowly spiraling inward toward its radiative tormentor. Eventually, probably within the next few million years, the planet will pass within the pulsar's Roche limit and be torn apart by tidal forces, ending its long existence as a radiation-blasted survivor. When that final destruction occurs, the planet's matter will be added to the accretion disk around the pulsar, creating a brief but spectacular display as the planetary material is superheated and torn apart at the subatomic level. The end result will be a slight increase in the pulsar's rotation rate and magnetic field strength, with no other trace remaining of a world that somehow survived one of the most violent events in cosmic history. The electromagnetic environment around this system is so intense that it affects space itself, warping the fabric of space-time in ways that can be detected by gravitational wave observatories on Earth. The planet exists in a region where the normal rules of physics are pushed to their absolute limits, where matter and energy interact in ways that test the boundaries of our theoretical understanding. Approaching this world in any conceivable spacecraft would be impossible due to the intense radiation environment, but even observing it from safe distances provides insights into the most extreme physical processes in the universe. The planet serves as a natural laboratory for studying matter under conditions that combine the most intense radiation fields with the strongest gravitational and magnetic forces known to exist. The discovery of planets around pulsars was one of the first confirmations that worlds could exist in environments far more extreme than anything we had previously imagined possible. These radiation-blasted survivors force us to expand our definition of what constitutes a planetary environment and challenge our assumptions about where planets can exist and what they can endure. But even as we contemplate the horror of worlds bathed in deadly pulsar radiation, our cosmic journey takes us to an even more disturbing destination. This next world represents perhaps the ultimate expression of planetary isolation, existing in a state of such complete disconnection from the rest of the universe that it challenges our understanding of what it means for an object to exist in space. This is a world that has somehow been ejected not just from its original solar system, but from its entire galaxy. It's an intergalactic wanderer, drifting through the vast emptiness between galaxies at speeds that carry it further and further away from any possible source of light or warmth. The distances involved in this scenario are so vast that they exceed human comprehension, representing isolation on a scale that makes our previous rogue planet seem almost cozy by comparison. Picture the cosmic violence required to accelerate an entire planet to intergalactic escape velocity. The gravitational interactions involved would dwarf the forces that create ordinary rogue planets, requiring encounters with supermassive black holes or other exotic phenomena that exist only in the most extreme environments in the universe. The planet would have experienced accelerations that could potentially alter its internal structure, creating geological stresses that no world should ever have to endure. The journey between galaxies takes place across distances measured in millions of light years, through regions of space so empty that individual atoms are separated by volumes larger than terrestrial buildings. This intergalactic wanderer exists in a void so complete that it makes the space between stars seem crowded by comparison. There are no reference points, no nearby objects, nothing but endless emptiness stretching in every direction. The psychological implications of such isolation are staggering to contemplate. If any form of consciousness existed on this world, it would experience a form of cosmic agoraphobia that no earthbound mind could comprehend. The night sky would be completely empty, except for the faint smudges of distant galaxy clusters, so far away that their light appears dimmer than the faintest stars visible to the naked eye from Earth. The temperature on this intergalactic exile would approach absolute zero, colder than the cosmic microwave background radiation that permeates normal space. Any atmosphere it once possessed would have frozen solid and fallen to the surface as snow within the first few thousand years of its journey, creating a landscape covered in layers of frozen gases that haven't seen liquid form for geological ages. But the true horror of this world's situation becomes apparent when you consider the timescales involved in intergalactic travel. Even at the tremendous velocities required to escape a galaxy's gravitational influence, the journey to the nearest neighboring galaxy would take hundreds of millions of years. The planet will spend geological ages crossing the void, with nothing but darkness and cold as companions for longer than complex life has existed on Earth. During this cosmic exile, the planet will witness the evolution of entire galaxies from a unique perspective. It will watch as the galaxies it passes between continue their own journeys through expanding space, slowly growing more distant as the universe's expansion carries them apart. The intergalactic wanderer will experience cosmic loneliness on a scale that encompasses not just stellar distances, but the very structure of space-time itself. The gravitational effects of dark matter might be the only forces this planet encounters during its intergalactic journey, creating subtle perturbations in its trajectory that slowly alter its course over cosmic time. These interactions with invisible matter would be the closest thing to companionship the planet experiences, gravitational whispers from the universe's hidden mass reminding it that it hasn't been completely abandoned by the cosmos. Eventually, after eons of travel through the intergalactic void, this wandering world might approach another galaxy and potentially be captured by its gravitational field. But by then, billions of years would have passed, and the planet would be entering a completely different cosmic epoch, populated by stars and planets that didn't exist when it began its journey. The possibility of such intergalactic worlds forces us to consider forms of planetary existence that transcend the boundaries of individual galaxies, creating a perspective on cosmic scale that challenges our galaxy-centric view of planetary systems. These ultimate exiles represent the far extreme of planetary isolation, worlds that exist in the spaces between the fundamental structures of the universe. Our exploration of cosmic horrors now brings us to a world that represents the complete inversion of everything we understand about planetary atmospheres and surface conditions. This is a place where the normal relationship between solid matter and gaseous atmosphere has been turned upside down, creating an environment so alien that it challenges our basic understanding of how planets can exist. The atmosphere of this inverted world is so dense and massive that it contains more matter than the solid planet beneath it. Instead of a thin shell of gas surrounding a substantial rocky body, we're looking at a massive atmospheric envelope that dwarfs the planetary core hiding somewhere within its depths. The pressure at the surface is so extreme that the atmosphere itself takes on properties more commonly associated with liquid or even solid matter. Imagine trying to descend through this atmospheric nightmare in a hypothetical probe. As you penetrate deeper into the massive gaseous envelope, the pressure and density would increase exponentially, creating layers of atmosphere so compressed that they begin to behave like different states of matter entirely. What started as recognizable gas at the outer edges would gradually transition into something more resembling liquid, then solid, then exotic forms of matter that don't exist under normal planetary conditions. The temperature profile of this atmospheric monster would be equally disturbing, with heat generated not just by external stellar radiation, but by the gravitational compression of the atmosphere itself. The deeper layers would be heated to temperatures that exceed those found on the surface of many stars, creating convection patterns so violent that they would generate atmospheric storms larger than entire planets. The chemical processes occurring within this atmospheric furnace would create compounds and molecular structures that exist nowhere else in the known universe. The extreme pressure and temperature conditions would force atoms into configurations that challenge our understanding of chemistry, potentially creating materials with properties that seem to violate the normal rules of atomic behavior. The boundary between the atmosphere and the planetary surface would be impossible to define with any precision. Instead of a clear transition from gas to solid, there would be a gradual continuum where increasingly compressed atmospheric material eventually becomes indistinguishable from the planetary core. The very concept of a planetary surface becomes meaningless in such an environment. Weather patterns on this world would operate according to principles that have no parallel anywhere in our solar system. The massive atmospheric envelope would generate its own complex circulation systems driven by the interplay between gravitational compression, stellar heating, and the planet's rotation. These circulation patterns would create atmospheric features so large and persistent that they would be visible from interstellar distances. The gravitational field generated by such a massive atmosphere would be strong enough to affect nearby space, potentially capturing and retaining material from passing comets or asteroids. Over time, this atmospheric giant might grow even larger as it accumulates additional mass from the interplanetary medium, gradually transforming from a planet with an oversized atmosphere into something more resembling a failed star. The formation of such an atmospheric monster would require conditions so specific and unlikely that their existence challenges our models of planetary formation. Current theories suggest that such worlds might form when gas giant planets migrate too close to their parent stars, causing their solid cores to be heated and partially vaporized while their atmospheric envelopes are simultaneously compressed and heated by stellar radiation. The evolution of such a world over cosmic time would be equally fascinating and horrifying to observe. The massive atmosphere would be in a constant state of flux, with material constantly circulating between the outer layers and the compressed inner regions. This circulation would create a form of atmospheric weather that operates on timescales of millions of years, with storm systems that persist longer than most species exist on Earth. The electromagnetic effects generated by this atmospheric furnace would create radio emissions detectable across interstellar distances, essentially turning the planet into a cosmic radio beacon powered by its own atmospheric dynamics. These emissions would vary in complex patterns that reflect the internal circulation and chemical processes occurring within the massive gaseous envelope. Standing on whatever passes for a surface on this world would be impossible for any conceivable form of matter, as the extreme pressure and temperature conditions would instantly vaporize any solid material. The very concept of a stable surface becomes meaningless when dealing with atmospheric pressures that exceed those found in the cores of gas giant planets. The optical properties of such a dense atmosphere would create visual effects unlike anything visible from normal planets. Light passing through the compressed atmospheric layers would be bent and distorted in ways that would make the sky appear to curve and twist, creating optical illusions that would disorient any hypothetical observer. The atmosphere itself would glow with its own light, generated by the countless chemical reactions and electromagnetic processes occurring within its compressed depths. This atmospheric nightmare represents the extreme end of planetary evolution, showing us what happens when the normal balance between solid planetary cores and gaseous envelopes is pushed far beyond the boundaries of what we consider normal planetary architecture. It's a world where the atmosphere has become the dominant component, relegating the solid planet to a minor role in the overall system dynamics. As our journey through these cosmic horrors continues, we encounter worlds that challenge not just our understanding of planetary science, but our fundamental concepts of how matter and energy can be organized in the universe. Each new discovery forces us to expand our definition of what constitutes a planet and pushes the boundaries of what we thought was physically possible in planetary system formation and evolution. The diversity of nightmare worlds we're discovering suggests that the universe is far more creative and terrifying in its ability to organize matter into planetary configurations than we ever imagined. Every new detection method and every improvement in our observational capabilities reveals new forms of planetary horror that exceed our previous understanding of what extreme environments can exist in nature. These discoveries are transforming our perspective on planetary science from a field focused on understanding worlds like those in our solar system to a discipline that must grapple with phenomena that exist at the very limits of physical possibility. The nightmare planets we're finding force us to develop new theoretical frameworks and computational models that can account for physical processes that don't exist anywhere in our local cosmic neighborhood. The implications of these discoveries extend far beyond academic astronomy, fundamentally changing how we think about the prevalence of habitable worlds in the universe and the likelihood of finding life beyond our solar system. Each new category of nightmare planet we discover represents another way that planetary environments can become hostile to life, narrowing the range of conditions that might support the development and survival of biological processes. Yet even as we catalogue these cosmic horrors, we continue to search for worlds that might share Earth's extraordinary characteristics, hoping to find other oases of habitability in the vast desert of hostile planetary environments. The contrast between the nightmare worlds we've explored and the rare, potentially habitable planets we occasionally discover makes each potentially life-supporting world seem even more precious and unlikely. Our exploration of cosmic nightmares has taken us to the darkest corners of planetary science, revealing forms of horror that challenge our understanding of how worlds can exist and evolve in our universe. These discoveries represent just the beginning of what promises to be an ongoing revelation of cosmic terror as our detection capabilities continue to improve and we peer deeper into the mysteries of planetary formation and evolution. The universe has had over 13 billion years to experiment with different combinations of matter, energy, and gravitational dynamics, and we're only now beginning to catalogue the results of those cosmic experiments. What we've learned should fill us with both terror at the incredible diversity of ways that planetary environments can become hostile to life, and wonder at the extraordinary circumstances that have allowed our own world to become the life-supporting oasis we know today. Every planet we've explored in this journey through cosmic horror represents a different path that Earth could have taken under slightly different circumstances. The delicate balance of factors that make our world habitable becomes even more remarkable when we consider the countless ways that balance could have been disrupted, transforming our beautiful blue planet into one of the nightmare worlds that populate the cosmic void. As we continue to push the boundaries of exoplanet science and discover new worlds beyond our solar system, we can expect to encounter even more bizarre and terrifying examples of what planets can become when the fundamental forces of physics are pushed to their limits. The universe's capacity for creating planetary horror appears to be limited only by the laws of physics themselves. And as we're learning, those laws permit configurations of matter and energy that our imaginations struggle to encompass. The nightmare worlds we've encountered so far have shown us planets in various states of destruction, isolation, and cosmic violence. But our final destination takes us to something that might be even more disturbing than worlds being torn apart or consumed by their stars. We're about to visit a planet so ancient that it predates almost everything else in the known universe, a world that has been silently watching the cosmos evolve for longer than most stars have even existed. This ancient world orbits a star so old and dim that it barely qualifies as a sun at all. We're talking about a red subdwarf, a stellar remnant that burns its fuel so slowly and efficiently that it will continue shining long after our own sun has exhausted itself and died. But this remarkable longevity comes at a price that transforms the entire system into something uniquely unsettling. The star produces less than 1% of the light that our sun generates, forcing this ancient planet to orbit incredibly close, just to receive enough energy to prevent its entire surface from freezing solid. The world completes a full orbit in less than 50 Earth days, racing around its feeble star at a distance that would place it well inside Mercury's orbit if it existed in our solar system. But here's what makes this scenario truly disturbing from an existential perspective. This planet has been locked in this tight orbit for nearly 12 billion years, experiencing the same dim red twilight for longer than our entire solar system has existed. When this world was already ancient beyond measure, the gas cloud that would eventually become our sun hadn't even begun to collapse under its own gravity. Picture what 12 billion years of stable conditions might have produced on a world with such extreme longevity. On Earth, evolution managed to progress from simple bacteria to human civilization in just 4.5 billion years. What might arise given almost 3 times that duration on a planet with completely different environmental pressures and challenges? The ancient world is almost certainly tidally locked to its dim star, meaning one hemisphere basks in eternal dim daylight, while the other endures permanent darkness. The temperature differential between these regions would create a narrow twilight zone, where conditions might theoretically allow liquid water to exist, assuming the planet retained any atmosphere over its incredible lifespan. Standing in that twilight region, you would witness a landscape that has remained essentially unchanged since the universe was less than a quarter of its current age. The rocks beneath your feet would have formed when the first generation of massive stars was still burning in the cosmic darkness before heavy elements, like carbon and oxygen, had been widely distributed throughout space by stellar explosions. The atmospheric composition of such an ancient world would tell a story spanning cosmic epochs. If the planet managed to retain an atmosphere over its 12 billion year existence, that atmosphere would have been slowly modified by geological processes, stellar evolution, and potentially even biological activity operating over timescales that dwarf anything we can meaningfully comprehend. But the most psychologically disturbing aspect of this ancient world is the possibility that intelligent life might have arisen there billions of years ago. If consciousness emerged on this planet, even relatively recently in its history, say within the last billion years, those beings would have had 1,000 times longer than human civilization to develop technology, philosophy, and understanding of the universe. Consider what such temporal scales would mean for any potential civilization. These hypothetical beings would have watched entire generations of stars be born, evolve, and die while their world continued its ancient orbit around its dim, long-lived sun. They would have observed the formation of our own solar system from across interstellar space, witnessed the ignition of our sun for the first time, and potentially even detected the earliest signs of life developing on the young Earth. The technological capabilities of a species with such temporal advantages would be literally incomprehensible to us. They would have had time not just to explore their own solar system, but potentially to spread across vast regions of the galaxy, establishing outposts and colonies around younger stars while their ancient homeworld continued its billion-year vigil in the cosmic darkness. If such beings still exist today, they would possess a perspective on cosmic evolution that would make them essentially godlike compared to any younger species. They would have solved scientific problems that we're only beginning to contemplate, developed technologies that would seem like magic to our primitive understanding, and accumulated philosophical and cultural knowledge across timescales that render human history completely insignificant. But there's also something profoundly melancholic about this scenario that goes beyond mere technological advancement. If intelligent life did develop on this ancient world, those beings would have experienced the ultimate form of cosmic loneliness. For billions of years, they would have been the only technological civilization in their local region of space, possibly in the entire galaxy, with no peers to communicate with across the vast distances between stars. The isolation experienced by such an ancient species would be fundamentally different from the loneliness we've encountered on rogue planets or other nightmare worlds. This wouldn't be physical isolation in empty space, but temporal isolation across cosmic history. They would have been alone not because of distance, but because they emerged so much earlier than any other potential civilizations that they had no contemporaries with whom to share their existence. Perhaps even more disturbing is the possibility that this ancient world might now be empty, its former inhabitants having transcended physical existence, evolved beyond recognition, or simply died out after exhausting the possibilities of biological existence. The planet might serve as a cosmic monument to intelligence so ancient that it predates every other form of complex life in the known universe. The surface of such a world would bear traces of geological processes that operated across timescales no other planet has experienced. Mountain ranges would have risen and eroded away dozens of times over. Continental drift would have rearranged the planet's surface features repeatedly. Any oceans that once existed would have evaporated and reformed countless times as the planet's climate slowly evolved over cosmic ages. If technological beings ever inhabited this world, evidence of their presence might be buried under billions of years of geological activity. Their cities, monuments, and artifacts could be compressed into metamorphic rocks or completely recycled by tectonic processes that operated over temporal scales longer than most stellar lifetimes. The very atoms that make up this ancient planet tell a story that spans cosmic history. The heavier elements in its rocks and atmosphere were forged in the nuclear furnaces of massive stars that lived and died when the universe was still young. The planet literally contains the ashes of stellar giants that exploded billions of years before our sun was even a glimmer in a nebular cloud. Standing on this world's surface, you would be walking on matter that has been recycled through multiple generations of stellar death and rebirth. The carbon in any hypothetical organic compounds, the oxygen in any remaining water, the iron in the planet's core, all of these elements were created in stellar furnaces and distributed by supernova explosions that occurred when the universe was fundamentally different from what we observe today. The magnetic field around such an ancient planet would have had billions of years to interact with its star's stellar wind, creating auroral phenomena that might have painted the planet's skies with dancing lights, for longer than complex life has existed anywhere else in the cosmos. These auroral displays would have served as a constant reminder of the electromagnetic dance between planet and star that has been ongoing since before most of the galaxies we observe had even formed. The gravitational relationship between this ancient world and its dim star represents a form of cosmic stability that few other planetary systems have achieved. While younger systems are still settling into their final configurations, with planets migrating inward or outward and occasionally being ejected entirely, this ancient system achieved equilibrium so long ago that it has remained essentially unchanged through most of cosmic history. But perhaps the most unsettling aspect of this ancient world is what it tells us about the nature of time and existence on cosmic scales. From our human perspective, 1 billion years seems like an incomprehensibly long time, but this planet has existed for 12 times that duration. It has experienced temporal scales that make our entire species' existence seem like a brief flicker in cosmic time. The planet serves as a bridge between the early universe and the cosmic epoch we inhabit today. It has witnessed the transition from a cosmos dominated by the first generation of massive stars to the current era of smaller, longer-lived stellar populations. It has observed the gradual enrichment of space with heavy elements as successive generations of stars lived, died, and scattered their nuclear products across the galaxy. If we could somehow access this world's complete history, we would possess a record of cosmic evolution spanning nearly the entire age of the universe. Every major astronomical event in our local region of space would be recorded in its geological layers, atmospheric composition, and potentially even in the ruins of civilizations that might have observed those events directly. The ancient planet represents the ultimate expression of cosmic endurance, a world that has survived virtually every form of astronomical catastrophe that could befall a planetary system. It has weathered the deaths of nearby massive stars, the gradual dimming of its own sun, potential asteroid impacts, and the countless other hazards that have destroyed younger worlds throughout cosmic history. Yet despite its incredible longevity, this ancient world also represents a form of cosmic horror that's uniquely disturbing. It's a reminder that consciousness and intelligence might be far older and more widespread in the universe than we've assumed, existing on timescales that make our entire species seem like a recent evolutionary experiment. The possibility that ancient eyes might have been watching the cosmos evolve for billions of years before our sun even formed challenges our anthropocentric view of intelligence in the universe. We like to think of ourselves as among the first technological species to emerge in our galaxy, but worlds like this ancient planet suggest that we might instead be among the youngest and most primitive civilizations in cosmic history. If beings from such an ancient world ever chose to make contact with younger species like ourselves, the encounter would be unlike anything our science fiction has ever imagined. The technological and intellectual gulf between us would be so vast that meaningful communication might be impossible, like trying to explain quantum mechanics to bacteria. The ancient planet forces us to confront the possibility that the universe might be filled with forms of consciousness and intelligence that operate on scales we can barely imagine, beings that have had billions of years to evolve beyond anything we would recognize as life or intelligence. They might exist in ways that transcend physical matter entirely, having long ago abandoned the biological substrates that gave rise to their consciousness. Standing on the surface of this primordial world, in that narrow band between eternal day and endless night, you would be walking on ground that has remained essentially unchanged since the universe was young. The silence would be profound beyond description, the silence of a world that has been waiting patiently for 12 billion years, perhaps for visitors like us to finally develop the technology necessary to reach across interstellar space and discover its ancient secrets. This ancient world serves as the perfect conclusion to our journey through cosmic nightmares, because it represents perhaps the most fundamental form of horror the universe can offer. Not the horror of physical destruction or environmental hostility, but the existential horror of realizing that we might be newcomers to a cosmos that has been watched, studied, and perhaps even inhabited by intelligences so ancient and advanced that they exist beyond our ability to detect or comprehend them. The nightmare planets we've explored today represent just a tiny fraction of the cosmic horrors that exist in our universe, but they serve as windows into the darker aspects of planetary formation and stellar evolution. Each world we've visited has challenged our understanding of what's possible in planetary science, while simultaneously highlighting the extraordinary circumstances that have allowed Earth to become the life-supporting oasis we know today. From worlds where rocks fall like rain to planets being slowly consumed by their own stars, from phantom worlds that never existed to ancient planets that predate almost everything else in the cosmos, these discoveries reveal a universe that's far stranger, more violent, and more terrifying than our comfortable earthbound existence would suggest. Yet even as we catalogue these cosmic horrors, each discovery also deepens our appreciation for the remarkable planet we call home. Earth's stable climate, protective atmosphere, and countless other life-supporting characteristics represent a combination of factors so unlikely that it approaches the miraculous when viewed against the backdrop of cosmic nightmares that dominate the universe. The universe is vast, ancient, and filled with wonders that challenge our understanding of what's possible in nature. But it's also overwhelmingly hostile to life, populated by nightmare worlds that remind us just how fortunate we are to exist on one of the rare planets where conditions have remained suitable for the development and survival of complex life over billions of years. As we continue to explore the cosmos and discover new worlds beyond our solar system, we'll undoubtedly encounter even more horrifying examples of what planets can become when the delicate balance of habitability is disrupted. But we'll also continue searching for those rare worlds that might share Earth's extraordinary characteristics, hoping to find other islands of habitability in the vast ocean of cosmic horror that surrounds us. The journey through these nightmare planets should leave us with a profound sense of both cosmic terror and cosmic wonder. Terror at the realization that the universe contains forms of planetary horror that exceed our wildest imaginings, and wonder at the incredible series of fortunate circumstances that have allowed our beautiful blue world to exist as a sanctuary for life in a cosmos dominated by death, destruction, and unimaginable hostility. Every breath we take, every sunrise we witness, every drop of water we drink represents a victory over the cosmic forces that have transformed countless other worlds into the nightmare planets we've explored today. We are living proof that even in a universe filled with horror, beauty, and life can still find a way to flourish, creating islands of meaning and consciousness in an ocean of cosmic chaos that stretches across billions of light years and billions of years of cosmic time. The nightmare worlds we've explored today represent just the beginning of what promises to be an ongoing revelation of cosmic terror as our detection capabilities continue to advance. Each new telescope we deploy Every improvement in our analytical methods reveals planetary configurations that push the boundaries of what we believed was physically possible in our universe. Consider for a moment the technological revolution that has brought these discoveries to light. Just a few decades ago, we had no direct evidence that planets existed beyond our own solar system. The first confirmed exoplanet discovery, around a sun-like star, happened in 1995, and now we've catalogued thousands of worlds, spanning every conceivable variety of cosmic horror. The methods we use to detect these distant nightmares are becoming increasingly sophisticated, allowing us to peer deeper into space and analyze planetary atmospheres with unprecedented precision. We can now determine the chemical composition of clouds on worlds dozens of light years away, measure wind speeds on planets we'll never visit, and detect the spectral signatures of elements being vaporized by stellar radiation in real time. But here's what should keep you awake at night. The detection methods we currently employ are biased toward finding the largest, most extreme examples of planetary horror. We're most likely to discover massive worlds that orbit very close to their stars, creating the kinds of extreme conditions we've explored today. This means that for every nightmare planet we've managed to detect and study, there are probably thousands more lurking in the outer regions of distant solar systems, hidden from our instruments but no less terrifying in their isolation and hostility. The smaller horror worlds, the ones that might be similar in size to Earth but subjected to forms of cosmic torture we haven't even imagined yet, remain largely invisible to our current technology. They're out there right now, experiencing their own unique brands of planetary suffering in configurations so exotic that we lack the theoretical frameworks to predict their existence. Think about what this means for our understanding of planetary formation and evolution. Every stable, life-supporting world like Earth had to navigate a cosmic obstacle course of potential disasters during its formation and early evolution. The fact that our planet managed to avoid becoming one of these nightmare worlds required an incredibly precise sequence of fortunate circumstances spanning billions of years. The timing of planetary migration within our early solar system had to be exactly right. If Jupiter had migrated slightly closer to the Sun during its formation, it could have gravitationally disrupted the inner planets, potentially flinging Earth into an eccentric orbit that would have turned our world into a frozen rogue planet or a superheated hellscape. The mass of our Sun had to fall within a very narrow range to provide stable energy output over geological timescales. If our star had been slightly more massive, it would burn through its fuel too quickly, becoming unstable and potentially destroying Earth's atmosphere with violent stellar flares. If it had been slightly less massive, Earth would need to orbit much closer to receive adequate heat, potentially becoming tidally locked, like some of the nightmare worlds we've explored. The presence of our unusually large moon, formed through a catastrophic collision early in Earth's history, has been crucial for maintaining stable axial tilt and creating tidal forces that may have been essential for the development of complex life. Without this stabilizing influence, Earth's climate could have undergone chaotic variations that would have prevented the long-term stability necessary for biological evolution. Even our position within the Milky Way galaxy plays a role in Earth's habitability. We orbit our galactic center at just the right distance to avoid the high-energy radiation environment near the galaxy's core, while remaining within the galactic habitable zone, where heavy elements necessary for rocky planet formation are sufficiently abundant. The more we learn about the requirements for planetary habitability, the more remarkable Earth's existence becomes. We're not just rare because we happen to orbit in our star's habitable zone. We're rare because we manage to maintain stable, life-supporting conditions through billions of years of cosmic evolution, while countless other worlds succumb to the various forms of planetary horror we've witnessed today. But perhaps the most sobering realization from our exploration of these nightmare worlds is how easily Earth could join their ranks. The delicate balance that maintains our planet's habitability is constantly threatened by potential catastrophes that could transform our beautiful world into one of the cosmic hellscapes we've described. A nearby supernova explosion could strip away our protective ozone layer, exposing the surface to deadly ultraviolet radiation. A close encounter with a rogue planet or stellar remnant could disrupt our orbit, sending us spiraling into the sun or out into the cold darkness of interstellar space. Changes in our sun's energy output as it ages could eventually turn Earth into a superheated Venus-like world, where the oceans boil away and the atmosphere becomes toxic to all known forms of life. These aren't just theoretical possibilities. They're inevitable aspects of cosmic evolution that will eventually affect every planetary system, including our own. The nightmare worlds we've explored today might represent glimpses of Earth's own distant future, showing us the various ways our planet could meet its end as the universe continues to evolve around us. Yet even knowing this, there's something profoundly inspiring about life's persistence in the face of such overwhelming cosmic hostility. The fact that consciousness arose on Earth despite the countless ways our planet could have become uninhabitable suggests that life possesses a remarkable tenacity, an ability to find footholds in environments that seem impossibly hostile. This resilience gives us hope that even as we catalogue more and more nightmare worlds, we might also discover forms of life that have found ways to survive in environments we previously thought were completely sterile. The universe might be filled with biological innovations we haven't imagined, life forms that thrive in the high radiation environments around pulsars, organisms that metabolize the exotic chemistry of tidally locked worlds, or ecosystems that flourish in the underground oceans of rogue planets drifting through interstellar space. The search for life beyond Earth takes on new significance when viewed against the backdrop of these cosmic horrors. Every potentially habitable world we discover becomes infinitely more precious when we understand just how many different ways planetary environments can become hostile to biological processes. The ongoing revolution in exoplanet science is transforming our perspective on humanity's place in the cosmic order. We're learning that we inhabit not just a rare planet, but an almost impossibly fortunate world that has managed to avoid the countless forms of destruction and chaos that characterize most planetary environments. This knowledge should inspire us to protect and cherish the extraordinary planet we call home, while simultaneously driving us to search for other worlds that might share Earth's remarkable characteristics. The contrast between the nightmare planets we've explored and the rare, potentially habitable worlds we occasionally discover makes each life-supporting environment seem like a precious oasis in the vast desert of cosmic hostility. As our exploration capabilities continue to advance, we can expect to discover even more extreme examples of planetary horror, worlds that will challenge our understanding of physics and force us to expand our definitions of what constitutes a planet. But we can also hope to find more worlds like Earth, rare havens where the conditions necessary for life have been maintained over the billions of years required for biological complexity to emerge and flourish. The universe is vast, ancient, and filled with wonders that exceed our ability to fully comprehend. It's also overwhelmingly hostile to life as we know it, dominated by nightmare worlds that serve as constant reminders of how easily the delicate balance of habitability can be disrupted. But even as we catalogue these cosmic nightmares, we must remember that our journey through the darkest corners of planetary science has revealed something equally important about the nature of existence itself. The horror we've witnessed on these distant worlds isn't just a collection of astronomical curiosities, it's a testament to the incredible creativity and relentless power of the physical forces that govern our universe. Every nightmare planet we've explored represents a unique experiment in planetary physics, a demonstration of what happens when the fundamental forces of nature are unleashed without the delicate constraints that make life possible. These worlds serve as cosmic laboratories where we can observe the extreme limits of what matter and energy can create when left to their own devices. The rock-raining hellscapes show us what happens when stellar radiation overwhelms planetary geology. The massive ring systems demonstrate the ultimate expression of gravitational destruction operating over cosmic timescales. The radiation-blasted pulsar planets reveal how stellar death can sterilize entire worlds, while somehow allowing them to persist as monuments to cosmic violence. Each of these discoveries has expanded our understanding of planetary science in ways that would have been impossible if we had only studied the relatively tame worlds of our own solar system. The nightmare planets force us to confront physical processes that exist at the very boundaries of what we thought was possible, pushing our theoretical models to their absolute limits. But perhaps most importantly, these cosmic horrors have given us a new appreciation for the extraordinary chain of circumstances that allowed Earth to become a sanctuary for life in a universe that seems designed to destroy it. We now understand that our planet's habitability isn't just a happy accident, but the result of an incredibly precise balance of factors that had to align perfectly over billions of years. The nightmare worlds we've explored today will continue spinning through the darkness long after our sun has died and Earth itself has become uninhabitable. They represent a form of cosmic permanence that transcends the brief flickering of biological existence, eternal reminders of the universe's capacity for both creation and destruction on scales that dwarf human comprehension. As we conclude this journey through planetary horror, we're left with a profound sense of both humility and wonder. Humility at the realization that we exist on one tiny island of stability in an ocean of cosmic chaos. Wonder at the incredible diversity and power of the physical processes that shape worlds throughout the universe. The next time you step outside and feel solid ground beneath your feet, breathable air filling your lungs, and gentle sunlight warming your skin, remember the nightmare worlds we've visited today. Remember that somewhere out there in the vast darkness, rocks are falling like rain, entire planets are being slowly devoured by their own stars, and ancient worlds are maintaining their billion-year vigils in the cosmic twilight. We are the fortunate few who won the ultimate cosmic lottery, born on a world where the conditions necessary for life not only exist, but have remained stable for the billions of years required for consciousness to emerge and contemplate its own existence. In a universe filled with nightmare planets that would destroy us in seconds, we have somehow found ourselves on the one world that nurtures us, protects us, and allows us to dream of exploring the very cosmic horrors that remind us how precious our existence truly is.